Okay, now that we know a few derivative rules, we're going to try an example where I have to find both a and b such that we'll make this piecewise function both continuous and differentiable. Now remember, for a function to be differentiable, it must be continuous. So we'll always start with continuity. So let's see, what must a and b be, as a double B, to be continuous? Okay, well, we know that to be continuous, g of x must exist at 1. So at 1, we would get a times 1 plus b. So it's a plus b. Oh boy, we're headed for some systems of equations, folks. So now let's look at the limit as x approaches 1 from the left of g of x. Well, 1 from the left would be the first piecewise function. So it would be 3 times 1 squared minus 4 times the square root of 1 plus 1. So we get 3 minus 4 plus 1. Oh, that equals 0. My, isn't that interesting? Well, we'll know that the limit as x approaches 1 from the right, we've actually already figured that out when we did the first step, and that will be a plus b. And our third condition of continuity says that the limit at 1 must be equivalent to the value at 1. And so we have found out that the limit at 1 is, actually, my bad. Sorry, let's redo that again. I don't need to go to the third step because the second step says that the limit from the left and the right of g of x must be equivalent. And so the limit from the left of 1 is 0, which must equal a plus b. And that's about as far as I can go in making progress on continuity. So now I've got to switch over to differentiability. And let's see if I can find out more about a and b that will help me in cracking this code. Because really, it's a puzzle. Okay, differentiability. Wow, that's a long word to spell. So in order for a function to be differentiable, the derivative as I approach 1 from the left must be equivalent to the derivative as I approach 1 from the right. So we must find the derivatives. So first of all, let's tackle 1 from the left. Well, 1 from the left is this function 3x squared. Well, this is not the derivative. So, I'll just write it. 3x squared minus 4x. Oh, it's the square root of x. Do you guys remember what power square root of x is? 1/2. Of course you do. I knew you did. Now, I must take the derivative of this function. Well, wow, I'm sure glad I know the power rules, because now I can just bring the 2 in the front. So 3 times 2 is 6, and then it's x to the first power. I can just write x. Minus, power rule again, 1/2 times 4, which is 2, and then I have to subtract 1. Well, 1/2 minus 1/2, no, 1/2 minus 1 is negative 1/2. And the derivative of a constant is always 0. Now let me clean this up a little bit. We want to put negative exponents, change them to positive. So whenever we have a negative exponent, we know that means that it has to be its reciprocal, so be denominator. So we want to find the derivative at 1. So now I'm going to plug in 1. 6 times 1 minus 2 over 1. So that means the slope of this function is 4 at 1 from the left. Well, what about the slope at 1 from the right? Well, 1 from the right is ax plus b. Now notice there's only one variable here. A and b are constants. So when I take the derivative, this is like x to the 1. So I bring the 1 to the front, and I get a, 1a, and then subtract 1, so x to the 0 is just 1. And the derivative of a constant is 0. So the derivative from the right is a. So if the derivative from the left must be equivalent to the derivative from the right, then we found that the derivative from 1 from the right is a, and the derivative from 1 from the left is 4. So a equals 4. Well, if a equals 4, then what must be equivalent to? Negative 4. Woohoo! That's some solid math there.